I usually work on multiple projects at the same time. The problem with this is, let's say I have this project, project one. Project one could require a version of dependencies like Node.js version 20 and then Mongo version 4. And then I could be working on another project altogether, project 2. And the dependencies for this project are entirely different versions. For example, Node.js version 22 and then Mongo version 5. You get the idea. Now, if I try to manage these dependencies for both of these projects via a local development environment, it basically becomes a nightmare because now I have to constantly switch different versions of these dependencies. And also there is this possibility that maybe if you're working with a team, so when you are in this case, you introduce even more variables in this scenario, even more things that could go wrong. And the reason why I say that is because now almost everyone's environment is different. So when you're working with a team and you do not have the system which makes the environment for everyone out there as same as possible, you can hear things like it works on my machine, right? And apart from all of this, I also have this habit of distro hopping. So what I usually do is sometimes I use Windows, and then sometimes I use Mac OS, and then sometimes I use Linux. So in these scenarios, whenever I do a fresh install, I have to basically spend a lot of time of mine in setting up the dependencies for this project. Essentially, setting up the project takes a lot of time in this case also. Now, if you can relate with any of these scenarios, I'm going to show you how you can fix this problem by using Docker in this video. So with the help of Docker, what we are going to be doing is we are actually going to Dockerize both of these applications, project 1 and project 2. And when we Dockerize both of these applications, they become completely independent of each other. Now, both of these projects contain their own dependencies, their own environment. So it becomes very easy for you to quickly start your project and start working on it. And Docker also provides you a way to quickly share this environment with people out there. That means everybody in your team can now use Docker and quickly set up their development environment. So Docker is actually a platform that allows developing, shipping, and running apps. Now, before we start writing some code about Docker, we need to understand 4 important terms you could say in Docker. And I'm specifically talking about these 4 things: container, image, Dockerfile, and then we also need to understand Docker Compose. Okay, let's try to understand all of these one by one. So a container provides an environment that contains everything that is required to run your apps. So it could include things like operating system, all of your code, dependencies, and then environment configurations, things like that. So a container is actually a very lightweight operating system in itself. And usually this operating system is Linux or Windows. So in most of the cases, you are going to use a Linux operating system in this one because that is going to create a container that is going to be very lightweight. Almost 90% of the time, we host our application in a Linux container only. Now, image is a read-only version of the container. Okay, so I don't know if you have this experience of manually installing either Windows or Linux in any computer. In that case, what you do, you actually download an ISO file. And this ISO file is actually an image that you can use to install Windows operating system on multiple of these machines, right? Now, similar to this Windows image, we have this Docker image. And this Docker image can be used to spin up multiple of these containers, okay? That means whenever you create any custom image, you can actually share the image with anybody out there using platforms like Docker Hub, and they'll be able to download that image and spin up the exact environment that you have created. Then we have this Dockerfile. So Dockerfile is your way of telling Docker, this is how it should create the Docker container. And the flow for this would work something like this. You essentially create a Docker file, and then Docker takes this Docker file and creates an image. And from this image, it starts a container according to your instructions, obviously. Okay, now the last thing that we need to understand is this Docker Compose. So Docker Compose is actually a tool that allows you to manage multiple Docker containers. Now, generally what happens is, let's say, if we take an example of a Next.js application, we divide this Next.js application in 2 parts, more like this. Let's call this service 1, and then let's call this service 2. You could imagine that both of these services are different Docker containers, Okay. Now the service one in this case could contain things like, let's say, Node.js version, and then all of your code. And then service 2 can include things like, let's say, MongoDB, right? Now the reason why would you create multiple containers, because things becomes easily manageable, you could say. You also have this reusable containers. That means I have this MongoDB container running. I can use this MongoDB database with my other projects also to store my data. So this basically follows this idea of separation of concerns. Now, to manage containers like these, which are actually part of a single project, we can use Docker Compose basically. With the help of Docker Compose, we'll be able to actually create these two containers at the same time. Then both of these containers will be connected with each other via a network, right? Both of these will be connected with each other via a network. This network will be automatically created by the Docker Compose itself. You also have this option of creating this manually. And then we can manage all of this with the help of Docker Compose. Okay, now let's start writing some code and see how do we actually Dockerize a Next.js application. So this is a to-do app that I have created in my CRUD video, very simple to-do application. If I talk about the dependency for this project, we only need two things. We need Node.js obviously, and then we need MongoDB database. So let's see how we can set up Docker development environment very easily. Okay, so the first thing that we need is Docker desktop application. You need to come to this Docker website and then you need to download the Docker desktop application depending upon the type of your computer. The only thing that you have to make sure that this application is running in your background, especially whenever you are working with containers in your system. Now I'll come to my project and then I'm going to create a Dockerfile. Now remember when I showed you this particular thing about containers, I told you that it contains its own operating system, all of the code, dependencies, and all of the environment configurations, right? So for this exact reason, we are going to start from this Node 23 Alpine 3.20 Linux image. Now let me explain what do I mean by this particular command. So first of all, Docker basically gives you this ability of setting up your entire environment from scratch. But if you try to set up everything from scratch, that is going to basically take you a lot of time. So what we do is we start from a base image, and then in this base image, we install all of the necessary stuff that we need for our particular container to quickly set up the development environment. Now Node 23 specifies that I'm talking about Node version 23. And then what you're seeing over here is Alpine 3.20 is actually a Linux operating system. So this is a very lightweight Linux operating system, which just contains everything that we need for our needs. Now, if you're wondering how did I get the name of this image, you can actually go to Docker Hub. You need to search for Docker Hub, and then you can come here and then you can search for anything. So let's say I'm looking for Node. So I'm going to search for Node. And then you can see all of the images associated with Node is here. I'm going to click on this first result. And then after that, you can see all of these supported tags and respective Dockerfile links. If you take a look at this, you can see that 23 Alpine 3.20. This is what we are actually using. So you could consider these tags as different versions of this image, Node image. And the way you write this is basically you take the name of the image, Node, as I have written over here, and then you put a colon, and then you specify the tag that you want to use. This is the one that I'm using, 23 Alpine 3.20, as you can see over here. Okay, so now we have basically used this base image, and then we are going to set up the working directory. And what this means is inside of this container, this is where I want you to place all of my files related to my container. And then I'm going to copy package.json file from the current directory where Dockerfile is present to the app directory of the container. So just because we have set the working directory to app directory over here, all of the subsequent command will be executed within this directory only. So when I say dot, I'm specifically talking about this app directory inside of the container. So this first argument is about file path of the host system, whatever file you want to copy from host. And then the second argument specifies where do you want to copy the file. So we're essentially copying the package.json file inside of the app directory. By the way, you can name this anything you want, okay? Then I'm not gonna run npm install directly. I'm actually going to install pnpm in this system. So I'm going to say npm install pnpm as a global dependency. And then after that, I'm going to do pnpm install to all of the dependencies based on this package.json file. And then I'm going to copy everything that is present in this directory inside of the app directory of the container. And then we are actually exposing port 3000. Now this is not actually exposing port 3000 out of the container. This is just for the documentation purpose. This is just to tell other developers that this container should expose port 3000 out of this container. We will be actually exposing the port 3000 when we'll be creating Docker Compose file in a bit. Now, the reason why we want to expose things out of the container to the host, so we can actually go to the browser and write something like localhost :3000. And we do a one-to-one mapping of these ports. So when I access localhost 3000 in the browser, I'm actually accessing whatever is present inside of this container, whatever is available inside of this container via port 3000. And then finally, you specify the command that you need to run after setting up all of this. And since I am setting the development environment, what I am going to be doing is I'm going to run pnpm run dev. But there's a problem with this. The problem is that I am also using Prisma. And before running this command, I actually need to push all the changes to the database and then generate Prisma client also. Unfortunately, I cannot do something like this. pnpm dlx prisma db push. So in the terminal, when you run your application, you can definitely do something like this. But if you want to pass multiple commands like this, in case of Docker, you need to use a little bit of different syntax, more like this. So with this sh and -c, what we are actually saying is that this subsequent string contains multiple commands. Read from this string and execute these commands one by one in order. So first thing that we are going to be doing is we're actually going to push all the changes to the database. It is also going to generate the client for me. And then I'm going to start the development server. Now, the next thing that we need to do is we need to create a Docker Compose file, dockercompose.yml. In the previous version of the Docker, you also need to specify a version that you're using. But in the latest version, this is not recommended. You do not have to do that. We are going to be starting from the services. And since this is a YAML file, the spacing is really important over here. So the first service that I'm going to be creating is this app service. And in this build property, I'm setting the context. And then I can specify the Docker file over here. To keep this simple, I can actually get rid of this. And I can directly set the build context like this. So with this, what I'm really telling is inside of the current directory, there's a file present called Dockerfile. Use that to create this particular container. And then in these ports, I'm specifying map port 3000 of the host to 3000 of the container. This is how we are actually mapping these ports. And I think this should be inside of a string. I can also specify a container name over here. Let's call this to-do app. And then I can specify that this container depends upon MongoDB. Okay, so we'll create this MongoDB container also in a bit. But with this, we are just specifying that our Next.js application depends upon MongoDB to be ready. So what Docker is going to do, it is first going to start that MongoDB container. And then after that, it is going to start this particular container. And why it depends upon that MongoDB? Well, the reason is pretty simple, because whenever we start this container, we are actually doing a Prisma DB push. Okay. Now we can also specify when this container should restart automatically. Now restart always is not recommended. What I'm going to be doing is unless stopped. So what this means is this is always going to restart automatically unless we stop this manually. Okay, in that case, it is not going to restart. Finally, we need to set up some volumes. Now, in case of Docker, there are essentially 3 types of volumes you could create. So first is actually a bind mount, which actually maps a host directory to the container directory. And we need this in our case because we want to see all of the real-time changes in the browser as soon as we make any changes to the code in our code base. So that means what we are going to be doing is we're actually set up a bind mount. So what I'm going to say, I'm going to put a dot. Dot essentially means this entire directory that you are seeing on the right side. It should be mapped with, so I'm going to specify a colon. And then inside of the container, we have set the working directory to app. So that is why I'm going to map everything from here to the app directory inside of the container. And then after that, by putting a colon, you can actually specify the strategy that we want to use. In our case, I'm going to use this cached flag. So by using this cached flag, what we are telling it to do is that you should sync project files with immediate host to container updates. What I mean by that is every single time I make a change in my host files, for example, all of these files, it should be reflected inside of the container very, very fast so that it then updates whatever we seeing in the browser. So that is why I'm doing something like this. This is called a bind mount. The second type of volume that we are going to be creating is this anonymous volume, which is going to store everything that is present inside of the container app directory and node modules folder. And the reason why we are doing this is because this node modules take some time to install. So if we put this in a separate volume, we can save a lot of time during the development itself. Now here's the interesting thing. Since this is an anonymous volume, every time your container gets destroyed, this volume will be destroyed also. However, in case of bind mount, since this is a direct mapping of host to the container directory, this is only going to be destroyed when you actually delete all of these files from the host itself. And finally, in a little bit of time, I'm also going to show you the third type of volume, which is named volume, when we'll be creating MongoDB container. Okay, so far for our Next.js application, we have specified the build context. That means here is where the Dockerfile is present. Docker is going to take the Dockerfile from here and then build our container according to the instruction present in the Dockerfile over here. Then we are specifying the container name, we're mapping the ports, and we are specifying that this container depends upon MongoDB. So do not start it unless this MongoDB is ready. This container will be started automatically unless we manually stop it. And then we are setting up our volumes. With this bind mount, we are specifying map these files and folders inside of the app directory of the container and use the cached flag so that we see the updates very fast. Then we are setting up an anonymous volume so that we can save ourselves a lot of time during the experimentation of what is working and what is not working. And then we can also specify the env file like this. Okay, so I think this is the only thing that we need to set up the Next.js project. Now the next container that we need to create is actually going to be MongoDB container. Okay, now this is really important. This name should match this exact name over here. Okay, this cannot be different. Based on this only, Docker is going to know which container you are actually talking about. Now for this MongoDB, I'm going to actually use an image from the Docker itself. I'm going to use the 8.0 version of Mongo. It is always a good idea that you provide a very specific version here, because if you do something like latest over here, you do not guarantee that things are going to be working as expected in the future. So that is why I always use a specific version of any particular image. If you notice carefully, when we are building the Next.js container, we are actually not specifying any image over here. And the reason for that is because we are using a Dockerfile. You can actually use a Dockerfile even in this case also, but it does not make sense in this case because it only makes sense in those cases when you need more control over how you actually want to create the Docker container. So that is why in case of MongoDB, it does not really make sense. I'm simply going to use the image that is available to me directly. Then I'm just going to set up few important things. Let's set the container name to MongoDB. And then for the ports, I'm going to map 27017 to 27017. And the reason why we are mapping specifically these ports, because by default, MongoDB runs on these ports only. Similarly, restart will be set to unless stop. That means it should run and restart automatically unless we stop this manually. We do not this env file over here. However, we do need a volume in this case because we want to persist the data. So in this case, we are actually going to create a named volume. And this is how you create a named volume. So with this, what I'm actually saying that create a volume called MongoDB data. And then this volume should contain everything that is present in the container directory DataDB. So this is where this MongoDB image or container is actually going to store its data. We are basically taking all that data, storing in this volume MongoDB data. And just for the named volume, whenever you create a named volume, in the end of the Docker compose file, you need to specify it like this. You only have to do this in case of named volume. Okay. And after these volumes, I'm going to set some environment variables which we need. So with this, we are actually setting the root username and root password. Again, this is just for the development environment. This is not recommended for production. Okay. If you want how to do all of this in case of production, just put a comment. I'm going to create that video for you. And finally, in case of this MongoDB container, I'm also actually going to be doing a health check. So this is important. With this, what I'm actually telling Docker to do, how it should determine if a MongoDB container is actually healthy and running as it should be. So what Docker is going to be doing, Docker is actually going to execute this command in an interval of 10 seconds, and the timeout is set to 10 seconds, it is going to retry for 5 times if it does not get the proper response. But if it does get the proper response, then this will consider this a healthy container, and then it is going to start this container because this container depends upon the MongoDB. So this is just a method for Docker to identify which container is healthy and which is not healthy. And then finally in the volumes MongoDB data, we can also specify driver local. And the reason why we are specifying driver local is because you also have this flexibility of storing these named volumes wherever you want. So in this case, we are doing this locally. That is why I've set the driver to local. Okay, so I think this is pretty much all of the things that we needed to add in the Docker Compose file. This one more time, what we are doing. We're actually creating 2 containers. The first one is this app container, which is going to hold all of the project code and Node.js. And then this second container is just going to spin up a MongoDB container. And then we are configuring all of these options over here. These will be connected with each other via a network, which Docker Compose is automatically going to be creating for us. Next thing that we need to do is we need to come to .env file, and then we need to update this database URL. So if you take a look at this, we're actually specifying MongoDB. Root is the username, example is the password. MongoDB is the name of the container and the port that it exposes. And then after that, we are specifying the DB. So you can basically place anything in here, whatever you want to set the name for your database. And then this is really important. You have to add this query parameter, auth source, and set it equal to admin. This is just to tell you how to authenticate this particular user. If we come to this Docker file, you can see that we are actually copying everything that is present inside of this directory to the working directory of the container, which is this app directory over here. Now, if you really think about it, it does not make sense in this case. For example, inside of the container, when we have copied this package.json file, we are actually doing a pnpm install, which is actually going to install all of the dependencies inside of the container itself. Then in that scenario, it does not really make sense to copy this node modules folder. You can even delete this folder from here itself if you want. So to tell Docker what files it should copy and it should not copy, we can use a Docker ignore file. And inside of this, you can specify what file it should not copy inside of the container. So I can actually skip all of these files, Dockerfile, Docker Compose, because I really need these in the host itself. I do not really care about Git. I only need this in the host. I do not really care about the node modules because I'm going to install this within the container itself. And these are some unnecessary files that we do not need anyway. Okay, so far we have created this Docker ignore file, Docker Compose file, and Dockerfile. That's all we needed to do to set up the development environment. Let me show you. So if I open the terminal and execute this command Docker Compose up, it is going to pull the MongoDB image, start the container, execute all the necessary commands, and then after that, we should be able to access the application by going to localhost 3000. So let's see if this works or not. My internet connection today is a little bit wonky. So let's see if this completes or not. The reason why this is taking so much of time because I'm actually pulling these images the first time. And also, yes, my internet connection is shitty right now. Okay, now you can see that we are executing those commands, npm install, pnpm, then we are doing pnpm install. And now it seems like the container is working. You can see that we have just executed this command Next.js, which is pnpm run dev basically. So if I come to browser and try accessing this localhost 3000, you can see that we are able to access our application. Now do not worry about this dummy data. This is the dummy data that we are seeing because of the caching reasons in Next.js. Now, even though it seems like things are working as they should be, there's a big problem. The thing is, inside of our project, we're actually using Prisma. And when you are using Prisma along with MongoDB, and you are trying to set up that in a Docker container, that is just a headache. And I'm not gonna lie, this basically took me a lot of time to figure out. Let me show you the problem first. So if I come here and try adding any to-do, you'll see that we are getting an unexpected error occurred. So if I come here and check the console, you will see that. So here you can see the error adding to-do, Prisma client known request error. And here's the problem. Prisma needs to perform transactions, which requires your MongoDB server to be run as a replica set. Now, replica set, if you do not know, is actually a group of multiple MongoDB servers, and they actually replicate your data across multiple nodes to make your database more resilient. And usually what MongoDB recommends is that you should have at least 3 nodes inside of a replica set. One of these nodes is going to be a primary node. Now, the benefit of something like this is that if for some reason this node 1 fails for whatever reason, MongoDB can intelligently switch to another node, keeping your application operational. First thing first, I'm gonna terminate this process, okay? And then I'm going to execute this command, docker compose down. I'm also going to pass this -v flag. So this is going to delete all of the containers associated with the Docker compose file that is present in this project. And -v is also going to delete all of the associated volumes also, as you can see over here. Perfect. Now I'm going to go inside of this Docker compose file. This time I'm actually going to create 3 containers. Okay. So first one is going to be app container, which is just going to contain the entire Next.js project. So this is almost the same that we had previously. We are setting the build context, we're setting the container name, mapping the ports, then creating these volumes, and then we are specifying that this depends upon this MongoDB setup. I'm going to talk about this in a little bit, okay? And then I'm specifying the environment variable env file. Now here comes the interesting thing. In the MongoDB, I'm using the Mongo image 8.0. The container name is MongoDB, and then the ports I am mapping over here. I'm creating a named volume, and this is the new thing, okay? I'm actually executing a command that is going to create a replica set with the name of rs0. And then this bind IP all basically allows all of the external connections. Finally, we have this health check like we had previously. We have created a container for the app over here. Then we created this MongoDB container, and then we have this MongoDB setup container. The only purpose of this container is to actually set up the MongoDB that we have present over here. And the reason why I'm creating a separate container to set up this particular MongoDB is because we want to execute some of the commands when this container is completely ready. That means we need to go inside of this container and then execute some of the command. So in this MongoDB setup, first of all, I'm using the same image, Mongo 8.0. Then I'm specifying that this depends upon MongoDB, and the condition of this particular MongoDB should be healthy. So first what Docker is going to be doing, it is going to create this MongoDB container. Let me zoom out a little bit if you are not able to see this properly. Okay. So first Docker is going to create this MongoDB container. When this is healthy, it is going to create this MongoDB setup. And then we are using Mongo shell. We are accessing the MongoDB instance present at 27017 port. And then within this instance, we are actually creating this config. And then we are calling this rs.initiate and bypassing the config. So this is actually how we are going to set up the replica set. And by the way, I'm only setting one node for this particular MongoDB setup because for development that is more than necessary. So here's what is going to happen. First, we are going to start this MongoDB container. If this container is healthy, we are going to start this MongoDB setup container, and then we are going to execute these commands. And with these commands, what we're actually doing is we are connecting with this MongoDB instance that is present in this port 27017. And then we are configuring the replica set. The restart no option here means do not restart this MongoDB setup container. So after this process is done, we are just going to delete this container altogether. And then if you take a look at this app container, so this depends upon this MongoDB setup. So when this MongoDB setup is completed, we are going to start this container and execute all of the necessary commands that we need. Now, the only thing that we need to do to make this work is we need to go inside of the .env file. We are going to delete these username and password because we do not need this. Okay. And then I'm also going to get rid of this query parameter. I'm just going to add this another query parameter replica set. And you just have to specify the name of your replica set. So I have named it rs0. This is what I'm doing over here. Let's see if this works or not. I'm going to execute this command docker compose up. And since I have changed a lot of things inside the docker compose file, so we'll have to tell this to rebuild the images from scratch. So we can do this by passing this build flag. Let's see what happens this time. MongoDB setup 1 exited with code 0. That essentially means that this is completed. Okay. And then after that, we are starting the container Next.js application. I think we have successfully pushed the changes to the database. Okay, that is a good thing. Yeah, it looks like your database indexes are now in sync with your Prisma schema. That means Prisma is working. Let's verify this by going to the browser. Come here, refresh the page, and now you can see the application. If I come here, create this one, you can see this is working. And the old data was gone because that was the catch data. Let me check all of these, if this is working or not. Okay, perfectly. So this is working as expected. So this is how you do it. This is how you set up the development environment for your Next.js application with Prisma, MongoDB, all of that things. So you now know that whenever you need to spin up your containers, you execute this command docker compose up, right? Now you can also pass this -d flag, which is actually going to start your containers in the background. So when I do something like this, it looks like something is not right. Let me see what is going on. I'm gonna execute docker compose up without -d flag. Okay, so it looks like MongoDB setup 1 exited with code 1. And let me see what is going on. Okay, so Mongo server error already initialized. Yeah, okay. So if we take a look at this docker compose file, we can see that inside of the MongoDB setup, when we are doing this, when we are connecting to this MongoDB instance, we are trying to initiate this every single time whenever we are starting the container. So this is not a good idea. We should add some sort of condition. It should only initiate if this is not already initialized. So I'm just gonna check if the replica set is already initialized. If this is not initialized, we are going to initiate it like this. And since now we have changed the docker compose file, we need to do a fresh build, more like this. Let's see. Okay, it seems like things are working. Let's see. Okay, the application is running. I'm able to add to-dos, update to-dos also. Okay, it looks like this is working. I'm going to terminate this process and I'm going to start this in the backend by passing the -d flag. And now you can see that our containers are working properly. So if I come over here and simply do this, I should be able to access my application very easily. Now here's the most interesting thing. Let me show you if hot reloading is working or not. So now I do not have to worry about starting the development server again and again every single time I need to work on this project. So I'm actually going to app page. And in this one, you can see that we have this to-dos. And right now we can see we have this to-dos over here. If I add something over here, save this, you can see that we are seeing the changes very, very fast. Perfect. That's all for this video. If you found this video valuable in any way, do like and subscribe to my channel. I will catch you in the next one. Thank you for watching.